This unit has the capacity to change the environment in which you enclose. Dehumidification has significantly changed our industry in relation to how we approach a job and how we can actually complete a job. So historically what we've done is we've been open to the elements in relation to how we can complete a job. So we are governed by what the elements do, and that is the environmental elements. So this unit here enables me to monitor and control the environment in which I encapsulate. So there's the trick, the encapsulation. So if I encapsulate an environment now, and we've got all these great pieces of equipment available to us, we can, with encapsulation, cladding, encompass, or totally control an environment with these particular units. So if I use a cladding like PowerClad, encapsulate the unit or the area that I wish to contain and monitor and control, this unit has the capacity to do that, and as I said, 3,000 litres a second. It's amazing. So how does it work? What it actually does is, with your encapsulated area and ducting, the utilisation of ducting, we put the ducting into the encapsulation. So then this machine will draw the environmental air from the enclosure and run it through this machine to what we call a desiccant wheel. So you've got fans that are drawing the air from the environment we've contained, running it through the machine. The desiccant wheel is picking up how much moisture there is in the air and processing that moisture. So the grains of moisture within a cubic metre can be controlled. So say for example, if you understand dew point dominates how we can coat a surface. This gives us the opportunity to control that dew point. So we're taking the moisture out of the air, and the desiccant wheel in this machine is removing the moisture and giving the air back to me. So it's drawing it in, processing it, and giving it back to me in such a state that it's moisture free and slightly warmed. So it's moisture free and slightly warmed. Well, let's think about this. What if it's really hot? Also with this particular machine, I can actually put an air conditioning unit on this so that I can cool the air before it goes in and comes back to me. But if it's cold, well, I can also put a heater on this, which we call a bank heater on the back of it, so that it's drawing warm air in, still processing the moisture within the air and sending it through to me nice and warm. So look at all the parameters I've got. If it's too hot, I can cool the air. If it's too cold, I can warm the air. But this machine is still removing the grains of moisture within that cubic metre of air that I'm trying to process. So its capacity is quite significant. So what are the features and benefits of that? Well, that enables me to not only control the environment that I'm trying to work in, but also too, the substrate that I'm working on is kept at an ambient temperature. So, hang on a minute, if the substrate's kept at an ambient temperature, I can work 24/7. So that's what I'm saying about this machine. It has significantly changed our industry with the introduction of controlled air. So if I blast an area, which is, say for example, a steel substrate, and I've encapsulated the area and I'm controlling the ambient air, the significance of that is that I can blast and leave the blast open. Well, what do you mean leave the blast open? I don't have to paint it. So I can go for days, even weeks, months if I wish to, as long as I control that environment with this particular machine. So if I can leave the blast open, that means that I can just continue to blast, then come back and blow the entire structure down and paint it. What a great advantage in relation to productivity. And that's what this enhances, the productivity, the availability to be able to blast something, leave it blasted, retain the blast, hold the blast, and then eventually come back and paint it when it suits me and I'm not controlled by the environment. So historically what we've done is we've blasted and tried to paint that blast to save the blast as soon as possible before the environmental or ambient temperatures affect the blast that I've just done. So in a a coastal environment, the added advantages are quite substantial because you've got salt in the air and so forth. So this particular unit, because you've encapsulated, controls the environment in which I'm in. So therefore, it might take on one side of it ambient air, but it will process that as well before it sends it through to me. So what we try to do is we do a circle. So the air within the encapsulation we have is the warm air or the controlled air is sent into the encapsulation, but then it's taken back out and processed through this and then put back into me. So it's doing a beautiful circle in relation to controlling what the temperature is, what the moisture is, and so forth. So bonus, bonus, bonus. In relation to productivity, it is a big enhancement, primarily because we can split shifts now. We can work 24/7 to get a job completed within a reasonable time. These machines are not difficult to operate, primarily because the functionality of it is controlled with a computer board. There's trip switches and so forth in there for the unit to trip in and out as it's required in relation to temperature, in relation to its ability to run and contain and maintain the environment in which I'm in. So you can see here the control board itself is relatively simple because it's all labelled in relation to what I'm doing. So the labelling on this particular machine is relatively simple as far as low temp shutdown, high temp shutdown. What that means to you is when this particular section is illuminated, low or high, all it's telling us is that we've exceeded the temperature parameters within the cabinet itself, and thermostatically it's picked up that we've had a temperature spike. Is it a common occurrence? No. The only time you'll have high temp shutdown is if our filtration's blocked or the machine's struggling to pull the air through, and primarily that is the cause. The low temperature shutdown is on the other side of that scale. So if, say for example, we have an influx of air and it can't cope with that volume of cold air, you'll have a low temp shutdown. Predominantly that is just a safety measure to keep this particular desiccant wheel and its heating capacity at a reasonable level that the machine can monitor. So is it a common occurrence? No, it's not. It's just a fail-safe in relation to what is processed as far as the air is concerned. The cubic metres of air that's travelling through the machine is monitored hot and cold. So peak high or low, this will pick it up. The rest of the information on here is, of course, a rotational shutdown. So say, for example, there is a problem with power, it's intermittent. This particular light here will illuminate. The rotational shutdown is primarily because of differentiation in power. So all of these things here are a nomination in relation to how we've set the machine up, basically. So say, for example, your genset runs out of power, you run out of gas, your filters are blocked, you'll start to see the illumination of some of these lights. A gas fault, basically same thing. You've run out of gas, the regulators are dirty. So how do I eliminate the illumination of any of these or the machine shutdown? It's relatively simple because you'll have a start up and shut down procedure for this particular machine. And the start up and shut down procedure also nominates any hazards that might be associated with running this machine. Leaking gas, faulty power leads, poorly maintained filters. All of these are indicative to the fundamental functionality of this particular machine. So if I abide by a start-up and shut-down procedure, ensure that everything's safe, put this in the appropriate place, give myself enough room to be able to work around the machine, give myself the opportunity to be able to do my daily checks, and they must be done. If you adhere to all that, the illumination of these lights is quite scarce. You'll notice on this machine too there's an emergency shut. So if I find that there's a problem with the machine, I can push the emergency stop. Also here you've got on and off, gas or electric. So just by flicking this switch to off in the center, the machine has the capacity to run on auto, so it can click in and out as it requires, the differentiation of air, temperature and so forth. And of course the on. The on is basically what we use for gas. The auto is more consistent with an electric feed for this machine. So emergency stop, then we've got our gas and electric and the system on and auto. So auto is basically what I'll run this machine if I'm running it on electric. I'll leave it on when it's on gas. Well, gee, what a variation. I can run it on electric or I can run it on gas. It's designed in such a manner that if I'm remote and I don't have the opportunity to be able to facilitate electricity, I can bring a genset on site and I can run it on gas. But if I have electricity available to me, I can just run it on electric on its own. So it has the capacity to either run on electricity or a minor amount of electricity to run your rotational motors, and the gas to ignite a flame to keep the temperature within the unit itself, the cabinet, to dry the air prior to, or warm the air as well, prior to the desiccant wheel. So the desiccant wheel, if you can envisage just a nice big round wheel, and what it is, it has the capacity, as it's turning slowly, to pick the moisture up. So it's like a silicon, the moisture sticks to the silicon, and as it turns, it has the capacity to remove the moisture from that, dispense it out this side, and give you the nice warm process air. Fundamentally, that's how it works. So when I said you can run it on gas or electric, if, say for example, I was remote and I wanted to run it on gas, what I would require is a 15 kVA genset. So the genset at 15 kVA has a capacity for the rotational motors on this particular machine. So the 15 kVA works in conjunction with the gas. So the gas itself, we've got here a 45 kg bottle. So that bottle will last me 5.2 hours. 45 kg bottle lasts me 5.2 hours. So what's that equate to? Approximately 16 litres an hour will facilitate the correct operation of this particular machine. So as you can see, the gas consumption is not significant. It's relatively low in relation to what the requirement is of this machine. So if I didn't need to use gas and I wanted to facilitate the supply from electricity only, the machine requires it to be initiated with the power on, and just utilise the electric switch and push the start button. Relatively simple. So when you start this machine, what it does, it goes through a startup system. So it starts the rotational motors running until the desiccant wheel gets to a stage where it can accommodate the moisture within the air. Then you'll hear another series of motors click in, and when they click in, that means that the whole unit is functional. You've got air being drawn from the atmosphere, run through the machine, processed and exhausted on the other side. So I'll show you how to appropriate the ducting in relation to what your requirement is, so I can recirculate the air within the encapsulation that I've designed or erected. And also too, if I don't wish to maintain that encapsulated, I can have drawn from atmosphere and totally fill the unit or the encapsulation with ambient air from outside, but still process through this particular machine. So you can see that it's got the adaptability to do what I want it to do. Primarily though, we're looking to harness the air within the encapsulation that we have and process that and maintain and keep that. So having said that, if we have an encapsulation, what are considerations that I need to have prior to building the encapsulation? One of the common oversights, of course, is the substrate on which we build our encapsulation. For example, concrete, bitumen and so forth. You've got to remember that this is drawing the air from the encapsulated area that I'm trying to control. So if it's drawing the air from that particular environment, and because it's harnessed, it'll also want to draw what's within the substrate itself. So say, for example, concrete, bitumen, so forth. All of these type of surfaces will hold moisture. So if I build an encapsulation, it's great. I've built the ceiling, the walls, but then I have to take into consideration, what am I on? Concrete, bitumen, so forth. So it's important to remember too that I still need to seal those as well. So not only do I need to put the cladding on the roof, walls, I need to also make provisions to put that on the floor as well. So what I've done now is I've made a little box that's all sealed up, and it's important where I join or overlap the cladding that it does overlap, that it is a good seam, it is a good seal, because it's important to remember that what you're drawing within that environment, it'll try to work from the out, any gaps, it'll try to pull that into the environment as well. It's just like when you're trying to warm a room. Say for example, it's the winter time. You know, if you shut all the doors and you've got the heater going, the room becomes nice and warm. Suits me fine. But you know yourself, if somebody leaves the room and leaves the door open, how quickly the environment tries to compensate back to its natural status, which in essence, it's cold outside, you've warmed the room. So if you leave the door open, the room becomes cold relatively quickly. This is the same concept. So it's important to make sure that it's sealed, and you give this the ultimate opportunity to be able to process that air in which you're trying to control. So remember that we're trying to ensure we maintain a blast. So if I spend all the time blasting that steel, all I have to do is ensure that the encapsulation is sealed, well built, and this will do its job to its optimum capacity. They're a great tool, and they have fundamentally changed our industry by being able to control the environment. What a plus. I can blast 2, 3, 4 days, a week, a month, and still maintain the blast. So if you can keep the moisture from your substrate and maintain productivity, this I could not recommend high enough, because it's such a great tool. It's not expensive to run, relatively simple to operate, and easy to maintain. On to the end of the control box here, we've got a series of switches, which stage 1, stage 2, stage 3. It's the heater control. So what this does is it initiates each stage of the heater bank within the unit when you're running the unit primarily off electricity. So when you're not using the gas side of things, you're using the electricity side of things to generate the functionality of this machine, you'll find that when you put the switch on the front panel there to electric, as I showed you earlier, what you'll do is you'll get the machine running, up and running, and then slowly you'll turn each bank on. So the whole idea of this is you don't go 1, 2, 3 straight up. So it's a periodic process. So you'll turn stage 1 on, you'll wait a few moments, that'll click in, you'll turn stage 2 on, you'll wait a few moments, and then you'll turn stage 3 on. So if you load them up too quickly, you'll get a shutdown light illumination come up, so you just know that you have to take your time in relation to turning them on. But they're set up like that primarily because it does need time to facilitate each heater bank as it comes on. So if you bang them all together at once, the load on your genset, so this is why it's here, the load on your genset is not overwhelming and the genset shuts down. So it gives everything time to appropriate itself. So just turn stage 1 on, wait a few moments, let it settle down, and you'll hear the genset, the draw on the amperage. You'll hear the genset change in its revs. Once it settles down, listen again, and so on. Don't turn them on all at once if you're running on a genset. If you're running on normal power, you'll find that you can click them in a bit quicker, but it does give the machine the opportunity to appropriate itself in relation to each heater bank that you turn on. Take your time, be patient, make sure it's right, make sure cables are installed correctly. 3-phase pins, make sure that the holding clamp is done up correctly and appropriately. And if you do find anything wrong with this particular machine as far as cabling and that's concerned, tag it out, write it up, tell BlastOne that you found a problem. Predominantly those problems originate during transport, and it can happen, not all the time, but it does happen. So common sense prevails. You find a problem, tag it out, ring up, say I found a problem. Just remember though, be patient with that one. So as we go around this machine, I want to explain to you what these particular items do. In the back here, you can see that there's a gauge. That is actually a magnehelic gauge. The magnehelic gauge works in conjunction with the other end as well. So it's not confusing or difficult. All it does is I'm looking for differentiation of pressure from one side to the other. So when I explain to you how that one works, when I get to the other end, you'll go, that's pretty simple. As far as this is concerned, you can see I've got the stainless steel swaged gas line, the gas bottle itself, a tap here, then I've got a series of regulators as the gas goes through. So what do I have to do to get the gas to work on this? It's relatively simple. Just make sure that when you attach the gas to the gas line to the bottle, this is a quick release, so you pull that particular swage back, put the connection in, then you can turn the gas on. What I suggest you do is make sure that where it's screwed into the bottle, it's tight. What I do have sitting here when I am working this with gas is I will have a small bottle of water and detergent, so that when I squirt that onto these fittings, I ensure that they are sealed. The last thing you want on site is gas leaking everywhere. The big plus with LPG, of course, is I can smell it. But I just make sure that when I do attach these particular hoses, a quick squirt just to ensure that they are sealed and there's no risk of any gas escaping. As far as this is concerned, it's all plumb and compliant to a standard. It is regularly serviced and checked at BlastOne, and the guys are quite pedantic in making sure that all the appropriate paperwork is filled out in relation to the gas side of this. So you can be confident that when you do get this particular machine on site, all of this has been checked and serviced prior to you utilising the machine. On the back here, we've got our operational procedure booklet with all the information in relation to this particular machine stored within this. I suggest you keep that closed so that the weather doesn't penetrate or permeate the paperwork within inside, so that you can read it and refer back to it if you have any questions. Further to that, if you have any further questions you can't find it in the book, ring the help desk at BlastOne. The guys will help you out. Everybody at BlastOne is conducive with the operation of this particular machine and can help you relatively quickly to get you up and running without losing time on site. On the end here, we've got the beginning of what we're going to discuss in relation to inlets and outlets. So this smaller one here is drawing the ambient air. So it will still take some ambient air whilst it's doing its due process in relation to what you're trying to control within your encapsulation. So what can happen is we're looking at how many times in an hour it can process the air. So it's sort of like breathing into a plastic bag. Not that I would recommend it. But if you breathe into a plastic bag, what you'll do is you'll exhaust the oxygen within that environment. Does that make sense? If I breathe into a plastic bag, I'll exhaust. Well, it does, because you're processing that air through your lungs. So ultimately, the air that's contained within that plastic bag becomes null and void or starved of oxygen. Basically, this does the same thing. So it still needs to draw a little bit of ambient air back through this, which is processed within the whole machine to ensure that the air where you're working within the cycles of air changes per hour are relative to what the moisture content is and what it's controlling. So as I say, it's just like breathing into a bag. Eventually we have to change out some of that air. That's what this does. There is, down the bottom here, your fire extinguisher And now we're starting to talk about these adjustable flaps, or the duct with inside this ducting housing itself. So what this is a damper adjustment. So it gives me the opportunity to dampen the air that's flowing through there. So what I'm doing is I'm restricting the free flow of air in relation to where it's going. But now we begin to make sense of what that magnehelic gauge was up there. This damper gives me the opportunity to control the magnehelic gauge, or the airflow that's coming through here. So the magnehelic gauge gives me an indication of where I need to be in relation to the standard operational procedure for this particular piece of equipment. So the magnehelic gauge up there, what I need to do is I need to have it on 1 to 1.5. So when we start the machine and we show you what that should look like, you'll go, oh yeah, that's relatively simple. So the equalisation of air, what we're doing for the machine is we're sort of like pumping one side up and holding the other side back, so that we get an equilibrium of air. Instead of it flowing through one side and just exhausting, the desiccant wheel doesn't have time to process that air. So it's sort of like a weight and measure. So if we hold one side up, we push the air in one side, we try and hold the other side up to give it a balance of air in and air out. Then the desiccant wheel spinning around like this, taking the moisture out, has the capacity to be able to process that correctly and send it out the other side. So this is the first of our dampers, and this is the air that's going out to you. So this is the air that is processed. So we are on the process side of the machine. So the air's already been dried and comes out this side. So you can see it's quite a big duct. And your ducting is relatively simple, because all it does is slides over the top of this, and then we put a clamp around the outside of it on that gland to hold the ducting on there. So when we start attaching ducting to this particular machine, we start to ensure also that all of this is clean, it's wiped out, and the ducting slides over relatively simple, because if the ducting's been dragged through the dirt and the mud, you'll find it's very hard to get it over this section. So by wiping it, making sure the ducting's clean, is it the right size ducting? Quickly sort out whether it is or not, because it won't fit. So the ducting that's sent with this machine is the appropriate ducting and does slide over the top. The one important thing to remember is that when you use the ducting on this, check it for damage, make sure it hasn't been perforated, and ensure that you do extend it to its capacity. Primarily because what you've got to remember is that this has got a massive volume of air that it's sending out and pulling in. So if your ducting's not appropriated correctly, the ducting can actually collapse on itself by being sucked into the ribs within the ducting. More so too, if you've got a hole in there, that means that it's drawing air out of here and not out of the encapsulation that I'm trying to control. So the webbing in the ducting, just check to make sure it's in good repair, there's no holes in the hoses, or the ducting I should say, and your clamps are appropriate in such a manner that they don't have air escaping. So really it's just common sense. If you make sure all those parameters are followed, and again, address your SOP, your standard operational procedure in relation to this, you can't go wrong. It is relatively simple. But the air coming from this side is actually, it's blowing it out. So you'll have no problem with getting the ducting to open up, because if you condense the ducting, what's going to happen is just like blowing up a balloon. It'll go and open up like so. So the ducting on this side, just make sure that you have arranged it in nice big radiuses, so when it goes like this and blows up, you'll find that it's in situ straight away. So just appropriate it so that it's not rubbing against anything and fibrillating on an area where it can fray the ducting. Also too, if you lay it on the ground, just make sure it's not on a rough terrain like big rocks and so forth, because it will tend to fibrillate a little bit and rub a hole in the ducting. So it's a good point to lay some power clad down first, sit the ducting on that. You can even use cardboard if you wish to, a canvas tarp. I really don't care in relation to what you elect, but what I do employ you to do is make sure you do put something underneath that ducting So now we've got to the process end of it. The process end, well, that was the end we were just talking about as far as the ducting that was sending it through to me. But here's another one of these gauges. So this is the process end of the gauges. So remember what I said, one side's bringing it in, another side's processing it. So in this end, it's processing it. So what we've got here is, if you can see, another one of these ducts and a control flap as well. So it gives me the opportunity again to control another aspect of it. So this is the outlet for what we call this dispelled air, or the dispensation of air not required, because this air here has actually got the moisture out of it. So where it's coming from the desiccant wheel and sent through the cabinet, when it comes out here, this particular air has the moisture in it. This is where it gets rid of what it's processed. So the air that's coming through from this motor is drawn out and dispensed out this side. It has moisture in it. It's not what we want. And you'll find too, on a high relative humidity day, when you're processing air, you'll actually get wet within a very short period of time. So the air that's coming through this particular end of the machine is the processed, dispensed with air. I don't need that. But this gauge here gives me the opportunity to start to equal things up. So this particular butterfly valve here, what I'm adjusting this for is to get this particular end up between 1 and 0.25. 1 to 0.25. So that's where I need to try and keep this end. So this gauge here is indicative to this butterfly here. So this butterfly valve here governs this gauge. So where I want this one is 1 to 1.25. So what this side of things does is, this is holding the air up. So if I shut that, this will fly around here to tell me that it can't expel the air. But what it does do is, gives me the opportunity to easily control the hold up of air. So remember what I said, I'm trying to keep things level, even here, and that is, I'm talking about the air. So this side here is actually holding it back for me, and gives the desiccant wheel the opportunity to keep some sort of equilibrium of the air that's running through the machine. So as you can see, it started to unfold as relatively simple. So process air, this is where the air is sucked in. So we've got two here, one on the other side, and processed air inlet. So what I'm doing with this one is, I'm actually running this to the job. So let's say, for example, this is my encapsulation. So as far as the encapsulation is concerned, there's my square, like so. So on the other side that I just discussed, which is the air that's already been conditioned for me, I'll send it in here, like so. So it's coming into my encapsulation. So these fellows here are drawing it from this side. So I've got the ducting here that's coming back and going into the induction side of the machine. What I have to be careful of here is, if there's dust within the encapsulation, or leaves and rubbish, things that can be easily picked up within a fanned, ducted environment, it'll be sucked into these particular vents and filters. So what I have to ensure every night, I take the ducting off and inspect these particular filter meshes for debris. So if it becomes overwhelming as far as the debris is concerned, it can dramatically affect the amount of air that travels through the machine. And that is when you may get an overheat alarm or a high temperature shutdown, because it can't get the air through it. So it's like drawing ice through a straw. It's trying to suck and it can't possibly get the volume of air through it. So things like this, it's a mandatory requirement that you check them every night. Also too, if you find that you're in the encapsulation and it is quite dusty, well, ultimately I would periodically during the course of the day check to see how this is coping with that particular environment that I'm controlling. Are they difficult to access? Relatively simple. 6 bolts on this end, they slide out. And you'll find that they will slide through the entire cabinet and come out this end. So what do I do? Would I wash them with a hose? All you need to do is blow them out backwards. So this is the front, you'll turn them over and just blow them out with a little bit of compressed air. So I'm not saying that you'd get a bull hose and blow the thing and the pleats disintegrate. What I am saying is common sense prevails. You'll take them out, arrange them in such a manner that you can blow them down with compressed air, keeping yourself safe, wearing the appropriate PPE, because there will be remnants of dust and rubbish that will come off those filters. So of course you'll wear eye protection, some earplugs, gloves, and of course a breathing apparatus, because what is it? It's dust. So I'd make sure they were blown out appropriately and replaced. So what I'm doing here is I'm going around the machine and I'm telling you what all these items do, but I'm also telling you what to look for and what to maintain in relation to its correct operation. So as far as these motors are concerned, there is one little trap for young players in relation to setting this up on site. As we go from state to state, there are sites that have their 3-phase power wired incorrectly, or when I say wired incorrectly, it's incorrectly as far as we're concerned, it's wired differently. So what can happen is when you go to site, you may have an alternate rotation for 3-phase. Normally what we do is we'll ring and say to the guys at BlastOne, I'm in Victoria. Is that a different phase setup for electricity than what you have there? Well, no, it's not. So just to make that clear for you, some sites we go to, the wiring for the 3-phase may be slightly different. So having said that, all I'm doing is making you aware of the fact that it's imperative with these particular motors that the rotation is correct. So what that consists of is if you plug this into power and you find that there's an arrow on the top of these outer housings to protect the fan, if you find that the fan's not spinning in conjunction with the arrow rotational spin, you think, hang on a minute, that's going backwards. All you need to do is contact an electrician or BlastOne and they'll send an electrician. What that means is all they have to do is reverse the 3-phase. So there's just 2 wires to reverse to bring this back in the correct rotational spin. So that's something I do check the minute I install this machine to make sure that the rotation for all these motors is correct. If it's not correct, of course the machine won't run properly. So when you first turn this machine on, you'll have one fan spinning that starts up drawing the air in. Now once the air gets to a stage where the machine can read that there's enough volume within the cabinet, the second one will start, and then the machine starts to work in due process. So when the primary motor starts, that's the first one I check, because normally if one of them's wrong, the rest of them will be too. So it's a relatively simple process just to have an electrician change the primary feed. So what I'm saying to you is these are set up and wired to Australian, they are wired to a standard. So if it's wrong on site, normally it's the supply power, it's not the machine. So it's the supply power in that they will change that phasing, not on the machine. So when we set this up earlier, you saw me adjusting that butterfly valve on the bottom there. That butterfly valve controls that magnehelic gauge. So what you've got to do is ensure that when you alter that butterfly valve, it is between 1 and 0.25. So the gauge is sitting in the appropriate place now. Letting that wing nut go and adjusting that butterfly valve alternates the pressure within the magnehelic gauge, so it reads it relatively quickly. So what I am saying to you is don't undo the wing nut, just flip the valve open or shut, because it has a detrimental effect on how that free flow of air comes through there. So what you will find is if you let that wing nut go and alter that butterfly valve too dramatically, you'll have an alarm come up on the machine that'll tell you overheat or cool air. So you'll have an excess of one or the other. So just gently adjust that butterfly valve get the magnehelic gauge to where I suggested you have it. Same on the other end. So if you do that, the machine will run beautifully. So don't close those off and don't restrict them too much, because the magnehelic gauge will reflect that relatively quickly, and the machine will read a differentiation and give you a high temp or a low temp shutdown. So just keep them in those parameters. Adjustment is minor. Lock the wing nut off when you've completed. Don't over tighten it, you will snap it off, and everything's good. So if you monitor that periodically during the course of the day, the machine will run beautifully. So now what we've done is we've run the machine. So we've got everything up and running. Gas is flowing beautifully. The one thing we need to check now is, are there any lights illuminated on the panel? No, there's not. They're all good. So remember what I said about adjusting those butterfly valves to keep that air equal within the machine? So a quick check to make sure that it's between 1 and 0.25, which is exactly where it is. So now I've checked that one. Just make sure its brother, the other side of it, is married to each other. So we'll go check that. So I've done those 2 checks. No lights illuminated. We're all good to go. So the only thing I need to make sure now is that this area is fenced off or perimetered in relation to this machine's operating. This is my environment, no one else's, so that I can check the machine's running. Do I have to stand here all day? Absolutely not. What I do need to do is do periodic checks throughout the course of the day to make sure that everything is operational. Remember what I said, if you have any problems, ring BlastOne and say, look, I've got a problem, this is not quite right, I don't understand it. What I do suggest you do is look in the manual and the documentation in relation to running this particular machine. Once you understand the fundamentals of it, which is exactly what I've just described, it's not hard. But if you're lost, ring BlastOne and say, listen guys, I need a bit of assistance. And they'll run you through the whole thing again. There are technical people here to be able to assist you with that type of operation. It's a great machine, does a great job. So if you make sure that you look after the machine in relation to clean filters, make sure the ducting doesn't leak, make sure your magnehelic gauges are the same or set in the parameters I showed you or outlined. Got plenty of gas. Have I got enough gas to last me the day? All of these things. Put your gas in place, ready to go. You can run this off a large bottle as well, so that you don't have to use these 45 kg bottles. You can use the bigger ones to facilitate continual running, and consequently on the larger jobs that's what we do. We'll put the bigger gas bottles in place, and it's only a matter of a quick phone call to ensure that you have got those organised to run the machine. Make sure that the fire extinguisher is not undermined by the weather or damage or accidental damage. And normally when they arrive on site, I will do a quick check around to make sure that nothing has been damaged and my ducting's in place. Do I have the clamps? Do I have the intermediate joiners for the ducting? Do I have the clamps for that as well? So fundamental stuff all comes together in a pattern or systematically. And if you have any problems, just ring BlastOne or check on the operation procedure in relation to the equipment. But it's a great tool and it does do a great job. And you can have more than one setup on site relative to the cubic metres in which you try to or endeavour to accommodate with dehumidification. So dehumidification, a great piece of equipment, and I can't, as I said before, I cannot stress, this is the way to maintain productivity 24/7. So thanks for listening to me, and I hope you take on board what this does avail to you in the opportunity to maintain and control an environment.